What are all your names? Sad thing is I think we have to choose.
Hi everybody. Thank you so much for joining us. Thank you for your patience. There's a couple network issues there, but we worked through them and should have some amazing footage for you of onboard cameras for the flight of Stardust 1.0. This is a bluShift Aerospace live stream of the launch of Stardust 1.0, our prototype sounding rocket. This will be the first commercial launch here in the state of Maine, and it will be the first commercial launch of a rocket powered by a bio-derived fuel in the world. It's a really big day. Some of us have been working towards this moment since November 2014. And well, it's just a little bit surreal that the day has arrived. Thank you everyone for your support and well wishes. I'll make a couple of announcements and then answer as many questions as I can. Alright, so we'll start with the good news. Stardust 1.0 has been cleared to 5,200 feet, significantly higher than the initial 4,000 feet expected. While we still will not be setting any world records for speed or altitude, this will be a historic occasion. As mentioned, the first commercial launch in the world of a rocket powered by a bio-derived solid fuel. And Maine's first commercial rocket launch as well. We're launching from the Loring Commerce Center, formerly the Loring Air Force Base up in Limestone, Maine. One of the requirements for launch is clear skies up to apogee, and right now we are delaying because of weather. Skies should clear sometime between noon and 1. That's our hope. All systems are go on the rocket. Just ran final tests on the telemetry. So at last report from mission control, all systems go, holding for weather. I noticed in chat someone asked if Maine is Canada. Haha. But in all seriousness, we are in basically a space race with Nova Scotia to develop small launch services to polar orbit. There's an effort here in the state of Maine we're proud to be a part of to build SpacePort, Maine. One of the sites being considered is the Loring Commerce Center for suborbital launch, and then for launch to a polar or near polar orbit. Of course, you need a coastal launch site for that with ocean overflight. Due south would be convenient So Maine would be the perfect place for that. So would Nova Scotia. So we've got to get there first. If you're just joining us, this is a bluShift Aerospace live stream of the launch of Stardust 1.0. Fully integrated rocket on the launch pad in the foreground here. And we've got some news about the weather. It looks like the forecast is not improving at this point. So the odds of launching by 1 p.m. have just gone down. Just holding tight for weather. Alright, so a couple of sources indicate very decent chance of launch at 1 p.m., but there doesn't seem to be general agreement across sources. Higher rates of agreement between sources that weather will clear up just before sunset. So we might be here a while. But, of course, this is Maine. Weather is unpredictable, and sometimes that can mean a lucky break. So we are all systems go, but holding to launch due to weather. Alright, if you're just joining us, this is a bluShift Aerospace live stream of the launch of Stardust 1.0, world's first commercial launch of a rocket powered by bio-derived fuel, and the first commercial rocket launch here in Maine. Currently we're holding for weather, waiting for the sky to clear. Looks like the outlook is a little bit brighter for noon to 1, so holding tight, fingers crossed for a launch at that time. Here Dodge 154 asked, is this just going to be a sounding rocket or will it eventually launch payloads? Good question. Well, this is a sounding rocket. It's about 20 feet tall, about 600 pounds fully fueled, and it's going to fly much lower than the vast majority of sounding rockets, however. So we're going to reach 5,200 feet above sea level, and sounding rockets can go anywhere from tens of thousands of feet to hundreds of miles, depending on the mission. So we won't be flying a kind of a normal profile for a sounding rocket, but it is a suborbital trajectory. Now, as we scale up, we do plan to develop Starless Rogue, a two-stage suborbital vehicle that can lift 30 kilograms to 150 miles. And also the Red Dwarf three-stage to low Earth orbit. GJ840 asks, why use a hybrid instead of a liquid? Wouldn't it be much easier to scale and be more efficient in general? Excellent question. Well, I shouldn't pretend my area of expertise is in liquid-propelled rockets here. But I would argue that we're shifting the efficiency around to production, and also only having a single set of plumbing in there for the oxidizer. There's fewer moving parts, it saves you weight, fewer things that can fail. So there's a lot of advantages. We don't have quite as fine of a control on throttle ability with a hybrid, but still enough that if you were to cluster the engines in a stage, you'd be able to steer the rocket through differential throttling. Too Far North asks, would the lowering location be of future use? And there's actually kind of a long answer there. There's an ongoing effort spearheaded by the Maine Space Grant Consortium, of which we're a proud affiliate, and certainly a stakeholder in the effort as well, to develop a spaceport here in Maine. Now, a number of sites, last I heard at least, were still under consideration. But there was a thought of launch control and business incubation and maybe payload integration, like a clean room and stuff, and data storage and processing down in Brunswick. Suborbital launch, either here in Limestone or based out of Limestone, depending if it's a horizontal launch like what Virgin Orbital is planning to do, or what Pegasus did, or vertical launch like what we're doing. And in theory, if permitting allowed, you could also do horizontal launch out of the former Brunswick Naval Air Station. And then also there's a call for a down east coastal launch site for launching due south with ocean overflight to polar and near polar orbit. Now, as for how the idea is progressing, it was considered as a bill in the last session. Maine's Idea B committee voted unanimously and with bipartisan support ought to pass on LD 2092, the bill to create a Maine Spaceport Leadership Complex. A Leadership Council. Now, the bill never made it all the way to the floor, as the state government kind of pivoted to focus on coronavirus. So I don't have the most current information on where we go from here in terms of state politics. But we did recently receive a sizable grant from the EDA to put together that leadership council, among other things. And I just dropped a link in our chat to a Maine Biz article on the Department of Commerce or Economic Development Administration grant to the Maine Space Grant Consortium. Excellent opportunity for some light reading as we wait for clear skies. see a couple of questions about cameras on board the rocket. Happy to say we've got 5 cameras. They're not on right now. The payload bay is powered down to save precious battery power. But we should have some really good footage for you guys through the flight. Mel Harris asks a shout out to MSSM students. Myself, I'm a proud graduate of the Maine School of Science and Math, just a couple minutes from our launch site here. So hey guys, hope you're having a good break. Hope you're keeping safe and healthy. And I'm sure that nobody has to tell you this, but study hard. Mindvent asks, how high are we going today? And the plan is to reach 5,200 feet above sea level. The maximum altitude was previously 4,000 feet. That was more of a permitting issue than a mechanical issue with the vehicle. We got cleared to the higher altitude for a couple of different reasons, but chief among them was just making sure that we burned through all the fuel during the main engine firing. There is a little bit of static on the feed. Sorry about that. We're piping sound through an FM transmitter for specially invited guests or tuned in their vehicles from a safe distance on the south end of the runway. We've mitigated the buzz as much as possible. There's tons of coils and ferrite beads here in the studio. But at the end of the day, we've got an FM transmission and a live stream coming off of the same source. There's going to be just a little bit of a buzz. Now, depending on how this launch goes, and depending on how our next round of capital goes, we may be able to resolve that issue for our next launch. Graham Edwards asks if we aspire to orbit for 2021. Sure, that would be amazing. I think we'll be pretty proud of ourselves if we make orbit by 2024. This year, assuming that the mission here goes nominal for Stardust 1.0, the focus moves to Stardust 2.0, which will reach higher altitudes, go through a more intensive permitting process, and lay the groundwork for the 2-stage suborbital rocket Starless Rogue, which will basically just use a Stardust 2.0 as the upper stage. My God, is that NASA spaceflight in the chat? That's amazing. Hi, guys. We're big fans. Probably no surprise. If you're just joining us, this is a bluShift Aerospace live stream and FM transmission of the launch of Stardust 1.0, Maine's first commercial launch and the world's first commercial launch of a rocket powered by bio-derived fuel. We've got 3 customer payloads aboard. We're ready to demonstrate our proprietary bio-derived fuel in flight and show also the growing demand for these suborbital flights. We've got a couple updates about weather and a new timeline. It looks like our best chance for good weather is going to be between 2 and 3 p.m. I'll say here it's a 50-50 shot. We don't really know what it's going to look like at that point. So with that in mind, the plan is to begin the oxidizer tank fill at about 1 p.m. Call the FAA to give our 1-hour notice. And weather permitting, we'll launch between 2 and 3 p.m. Now the outlook is, given what the weather looks like for the rest of the day, if we have to abort the launch, it's probably a scrub, and we would probably be looking at a new launch date early next week. For folks in other time zones, 2 p.m. will be just over 2 hours from now. Someone in the chat asked our FM frequency. It's 92.9 FM. There really isn't not much distance on that, so unless you're on the south end of the runway, probably live stream is your best bet. So Stardust 1.0 is a single-stage vehicle. It will, however, split into 2 bits. You can see our launch sponsor, Rocket Insights. You can see their logo on the lower half of the vehicle. There's a line right above it. And that horizontal line is where at apogee Stardust will split into 2 sections connected by a tether. A drogue chute will come out, and then main chute will deploy roughly 1,000 feet above the ground. Someone asked, Hyder, does the company have a Patreon? Why, yes we do. You can look up bluShift Aerospace and Patreon, and I'll drop the link in just a minute. Now, I saw somebody asked about our payloads. Glad you asked. We've got 3 of the 3 available spots. All were filled, and we're already starting to book client payloads for the flight of Stardust 2.0. So Falmouth High School is an excellent representation of kind of an academic customer. Falmouth High School here in Maine worked with the University of Maine and the University of Southern Maine to outfit their CubeSat prototype with a GoPro radio transmitter and Xenobox chips to collect flight data, including acceleration, pressure, temperature, and humidity. Not directly related to this mission, but congratulations are certainly warranted. Falmouth High School also helped develop the imager payload that will fly aboard MESAT-1, Maine's first CubeSat, or first orbital CubeSat. They're still called CubeSats even on suborbital missions. Certainly they are not satellites, but the form factor is kind of convenient in how standardized it is. So Falmouth High School's imager payload will fly aboard MESAT-1, first orbital CubeSat. Imager is specifically modified digital camera for imaging shallow coastal waters to distinguish water quality properties such as turbidity and concentrations of phytoplankton. Another payload will be from Kellogg's research labs. These guys are a really good example of an industrial client. So aboard their CubeSat enclosure, Kellogg's Research Labs is going to be testing the vibration dampening properties of nitinol, a shape memory alloy of nickel and titanium. They're going to test its behavior in the conditions of a rocket launch, specifically looking at how the shape memory alloy can take vibrational energy and turn it into heat energy, potentially dampening shock for systems aboard a CubeSat. Now, at this point in the game, Kellogg's is certainly no newcomer to aerospace. They've supplied parts for more than 100 satellites launched in 2019 alone. So we're really excited to have them flying with us and testing a new application for this material. And our last commercial payload comes from Rocket Insights, software development company. They will be filling their CubeSat enclosure with traditional Dutch wafer cookies called stroop waffles, as an homage to their Amsterdam-based parent company, Dept. Now, the plan for this mission was to have a camera in the payload bay, no matter what. But when we realized that there were going to be stroop waffles flying in a pseudo-microgravity environment for about 11 seconds, we worked really hard on that camera in the payload bay. So if all goes well, sometime between 2 and 3 p.m., you'll get to see some stroop waffles in microgravity. Scrap Over Engineering asks, what was the name of the Amsterdam-based company which sends the stroopwafels? I believe it's Dept. Delta Echo Papa Tango. Dept. A couple people from Rocket Insights came up to watch the launch, and some of them are even helping direct traffic, which was just amazing. Really, like, just fun people. There's some questions also in chat about the reusability of the vehicle. Stardust 1.0, of course assuming nominal flight parameters, is fully reusable, save for this tiny little kind of tined collar of metal down at the base of the vehicle.
Ooh, that would have been very cool.
It almost looks like the back of a jet engine, but it's not. Its purpose is twofold. First of all, it's a little bit of a crumple zone during the litho braking maneuver. The Marvel or modular adaptable rocket engine for vehicle launch is going to split off from the payload bay, and they'll descend tethered together, and then once the main chute comes out, the engine will touch down first. This means that the payload bay will have several seconds of additional deceleration for a softer touchdown. But when that Marvel touches down, it just seemed like a good idea to have something to absorb shock. So those tines will probably crumple a little bit, and we'll switch them out for the next launch. Now the other purpose of those tines is to help keep brush away from the engine nozzle in case it still is warm. That engine should be very thoroughly cooled by the CO2 flush after main engine cutoff. I say main, of course there's only one engine. After engine cutoff. And also the air 5,000 feet above Limestone, Maine, I'm sure will do a terrific job of cooling the engine. But in the event that it touches down hot, those tines will also, crumpled or not, just help keep stuff clear of that nozzle. Anyway, that one component isn't reusable, but everything else, if the flight goes to plan, will be. Now, down the road, as our rockets carry heavier payloads and they go higher and farther, reusability is very much on the drawing board. Can't go into any specifics here. But if you want to do new space at this point, you pretty much have to be thinking about reusability, and that's a good thing. If you're just joining us, this is a bluShift Aerospace live stream of the launch of Stardust 1.0, our prototype sounding rocket. This marks the first commercial launch of a rocket here in Maine and the first commercial launch of a rocket powered by a bio-derived solid fuel in the world. Currently, we're holding for weather. We'll be flying to 5,200 feet today and need less than 50% cloud cover at that height. We were previously cleared to 4,000 feet. Got it bumped up to 5,000, but it sounds like there's pretty steady clouds everywhere above 2 for now. There's a good chance that the weather will clear up between 2 and 3 p.m. If that doesn't work, then the chances are we're going to scrub for weather and reschedule to next Tuesday or next Wednesday. All right, in the chat on our live stream, I see some folks questioning why one would launch from Maine, specifically referencing our, well, I guess what you could describe as excessive latitude. Now, it's true when you go to orbit, the closer you get to the equator, you get kind of a bump from the Earth's rotational speed. And it'll shave about 1,000 miles an hour of delta V off of what your rocket needs to do to achieve orbital speeds for an equatorial or low inclination orbit, proceeding from west to east. If you launch from higher up, then you need to spend more fuel, essentially going sideways, until you achieve such a great sideways velocity that the ground curves away at the same rate that gravity pulls you down. Thus, you achieve orbit. So, why then launch from a high latitude? Well, for a high inclination orbit, such as a polar orbit, where you go over the South Pole, either perfectly or very nearly, and about 45 minutes later, because low Earth orbit, right? 45 minutes later, you're halfway around the world at the North Pole, another 45 minutes back at the South Pole, while the Earth is rotating under the satellite. It's a terrific orbit for communications, for Earth imaging. And so for an orbit like that, you need to cancel out the Earth's rotation. So if you're trying to reach a polar or near polar orbit, launching from the highest latitude possible, either as far south or as far north as is reasonable, gives you fuel savings. Basically the same kind of fuel savings you would get if you could launch comparably close to the equator for a polar orbit at the same altitude. So with Maine's high latitude and south-facing coastline, in down east Maine, you've got about 1,800 miles of ocean over flight. So it's a safe and efficient way to launch to polar and sun-synchronous orbits, while still contiguously connected to the United States eastern seaboard. And with some really terrific accommodations. We are vacation land. We're also going to be rocket land, though. The future of space will be made in Maine. Gaming Cube 47 asks, when are we planning to reach space? On purpose, I assume. In all seriousness, in about 2 years, if all goes to plan, we'll be launching Starless Rogue. That's our 2-stage suborbital. And that can get up to 150 miles, so well above the Kármán line. And so, first flight of Starless Rogue, that'll be when we reach space. Jan Piotrowicz asks, how big is the team that made this rocket? Between employees and interns and contractors, at any given time there was probably about 10 people, give or take, working on this project over the past 6 years. Cost of Stardust, the launch pad, the R&D that went into both. If you factor in donated person hours there, close to $1 million getting to this point. All right. We've got a more specific number on the cost of Stardust 1.0 here for you. Factoring out more general company expenses, the rocket and the tower together is about $260,000 with labor and materials and other supplies. I got a couple of requests to cancel the background music. That may make the buzz a little more prominent, but if a lot of people feel that way, we can definitely pull down the music. All right. The people have spoken, the music shall stay. Someone asked how many engines Stardust Rogue is going to have, the two-stage suborbital. It's a cluster of 4 engines on the first stage, and then a single engine on the second stage. Well, if you're just joining us, this is a bluShift Aerospace live stream of the launch of Stardust 1.0. This will mark Maine's first ever commercial rocket launch and the first commercial rocket launch of powered by a bio-derived fuel ever. Currently, the rocket is doing all right. All systems go. The weather is a bit of an issue. Due to cloud cover, we're holding from a launch that was originally scheduled pretty early this morning. We're now looking at 2 to 3 p.m. as our window for weather. Getting a lot of comments in chat about the fuel. Feel free to keep discussing it, of course, but I just can't really comment on it. Happy to answer other questions, though. I can talk a little bit about hybrid rockets. Well, it's funny. Someone asked if I used to be a radio DJ. Ryan, the answer is yes. In fact, that's how I met the CEO. I had a radio talk show about space science and exploration in Portland, Maine, and I found out about this rocket company up in Brunswick on Facebook. And so we had a little back and forth, and we got the CEO in to do an interview. We had so much fun that we did 2 interviews. And before I knew it, I was interviewing for bluShift. I had to step away from the radio show to focus on bluShift, but it continues. All of the other panelists are still there on WMPG as Scientifically Speaking. All right. We've got a little bit of a treat for you. bluShift founder and CEO Sasha Derry is going to join us in just a couple of minutes for a quick Q&A. Hey, Michelle. Griffin asks, wondering if the fuel being used could be efficient for launches on the Moon, Mars, etc. I can say that that is on the drawing board. Right now we're experiencing temperatures comparable to those at the Martian equator, although the pressures, well, there's more here. Alistair Mitchell asks, what materials are you using for structures? Well, the skin of the rocket is a composite, and the internals are a mix of aluminum and steel. Steel mainly for affordability. It's very rare to see that on a rocket, and certainly, our future rockets will have more aluminum, less steel. If you're just joining us, this is a bluShift Aerospace live stream of the launch of Stardust 1.0, Maine's first commercial launch and the first launch commercially of a rocket powered by bio-derived fuel. We're holding now for weather, expecting clear skies somewhere between 2 and 3 p.m., or at least clear enough to launch. All systems are go on the vehicle. And as we wait, I am joined here by Sasha Derry, founder and CEO of bluShift Aerospace. Sasha, hello. Thank you so much for taking time to join us here.
Good afternoon. Thank you, Seth, and everybody who's out here for suffering through this cold.
Well, someone asked if I had experience as a radio DJ, and I told them how we met.
Yeah.
And this is really bringing back some memories.
Full circle.
Yeah. So how's it been for you today? Before bluShift was incorporated, you were already working towards this day. So we're talking over 6.5 years at this point, right?
Yeah, this is 6.5 years of the accumulation of 6.5 years of hard work of many individuals, and hardly just me, but a lot of really talented individuals to get us here. And it could be a historic moment if we can light this candle. We'll be setting possibly 2 new records, being the first commercial vehicle rocket to launch from Maine, and being the first commercial launch in the world using a bio-derived carbon-neutral fuel. Now, I know a lot of people are going to guess that it's blueberries and manure or ethanol. It's none of the above, but we can assure you it's bio-derived and carbon neutral. But this is incredibly exciting for all of us, and I think there's a lot of anxiety, but we're feeling pretty good right now. Everything technically is in place, and it's just the weather.
Yeah, it really is everything on the line in this moment, and I'm lucky, because none of the buttons that I touch here are going to make anything explode.
Right, thank goodness.
Yeah.
Unlike what happened last night. No, sir.
No. But it's just been really amazing to see you guys collaborating and problem solving through the static fire tests and through the past couple of days as we get the rocket up on the tower.
Seth, you and I have been here since Sunday, setting up the network, getting systems ready, and the rest of the guys came in on Monday and Tuesday. But our engineering team, Luke, Brooke, our interns, Ben, other guys, Mike and Corey and Gerard and others, David Hayricken, have been so instrumental into getting us to this point. And not everybody could join us here. And there's many people who are part of the bluShift team that some live far away, and they've contributed over the years. Whether it was 6 years ago, 3 years ago, or this week, people have been working early mornings, through the days, and late into the night to push this effort forward for bluShift, in this case also for Maine, but also to demonstrate how a small launch vehicle, how we can provide ultimately dedicated small launch vehicle access for tiny payloads to space.
Yeah, so let's talk about that a little bit, because a lot of companies right now they're going for volume, right? I mean, SpaceX is launching like a lot more CubeSats in one go than we ever planned to. We're doing 30 kilograms, and that's it. So we're not competing with them. We're not even competing with Rocket Lab, really. We're carving out this new niche. Why are we doing that?
Well, I'd like to say, if you bring it down more terrestrially, it's kind of like SpaceX is the freight trains to space, and there's definitely a market for that, a big market for that. There are bus lines to space like Rocket Lab, Virgin Galactic, and Virgin Orbit, and others. And what I expect us to be, is the Uber to space. We're going to be able to, because of our technology, where we're launching from here in Maine, ultimately off the coastline into polar orbit, but how we're going to be operating this company, I believe that we will be able to launch profitably 1, 2, maybe 3 payloads at once in our payload section. For most rockets, they need to collect either very large payloads or dozens of payloads at once to turn a profit. So we think there is a real niche market for us that's currently not tapped by many other companies in the world.
And bluShift is one of the things that makes bluShift so cost competitive is the fuel has a 0 TNT value. There's no cryogenic storage or anything like that, so the handling costs go down as well as the manufacturing costs. And my favorite fact about the fuel is that, well, I don't know if we can call it edible exactly.
No, although I think you could find components of our blend in food products, but yeah, you could eat it. I probably get in trouble for saying this for the bajillionth time, that I could feed it to my daughters, and the worst thing that would happen is they might get constipated, but I wouldn't do that to them, I swear. But it's a very safe fuel. In fact, I tossed one of our sample fuels, a small subsection of it, a few days ago with some neighbors onto a fire, and everybody stood far away, and it is no more explosive than a piece of wood. It just burns.
That's amazing.
Yeah. Now another important aspect about why we're able to keep the cost down has to do with the hybrid rocket technology itself. It allows us the throttability and control that a liquid fuel rocket has, but half of the valving and control systems, the tubing and solenoid valves that you might need on a liquid fuel rocket. And that means a lot. That means not only a lot during manufacturing, but of course during the research and development phase, a whole lot less complexity. And because neither our fuel nor our oxidizers are toxic, that means the handling costs are quite a bit less. Launch environmental costs are negligible, except for when we first get our permit costs. And it means that we can feel confident that when we launch off the coast of Maine, that we will not be contaminating fisheries, wildlife, or habitat, or affecting habitat. Something I think that you can't say about many rockets in this world today.
Yeah, so about that, because it's not just a bioderived fuel, it's also a non-toxic fuel. There's no heavy metals, no rubber, unlike some other companies that are operating vehicles that use a hybrid rocket right now.
Sure. Yeah, exactly, like Virgin Galactic, Virgin Orbit. Yeah, I mean, you can carry our rocket down the road without any special DOT rating with the fuel in it. Maybe not the oxidizer, but certainly with the fuel. And there are zero hazards other than the kinetics of the rocket going down the road for folks. Field questions for 5 or 10 minutes. I know we're preparing to call the FAA again as we narrow down upon the launch window.
Yeah, all right. Let's go to YouTube for comments here. Well, I don't think we have. Oh, here we go. So JJ840 asks, what should I do or learn to get an internship? We take all our interns through the Maine Space Grant Consortium, through their Aerospace Workforce Development Program. So that's who I would reach out to there. And Sasha, I don't know if you want to leapfrog off of that, but also they ask, how was the engine designed and what's the nozzle and casing made of?
Sure. So, with a hybrid rocket, the fuel, hybrid rockets can work multiple ways, but we have our fuel inside the casing, lined inside of our combustion chamber. Right now, we use, our engine has not been lightened for normal flight. It's quite literally the one we use as our test engine when we were working to optimize its performance and stability under a NASA grant. However, so the encasing itself is a metal casing, and the nozzle right now is a graphite nozzle that we're using currently. We have plans. Certainly the casing will change for Stardust 2.0, and the nozzle, we have some interesting changes for the nozzle as well that I can't get into yet.
Well, maybe we can have a big reveal next launch.
Yeah, hopefully.
All right. So back to one of mine. Another pain point of a lot of folks that are trying to launch a CubeSat is they need to use a crew-rated launch vehicle, and so we're planning to sidestep that by just producing rockets that really couldn't have a person in them anyhow.
Yeah, that's right. We, one thing that we learned when we interviewed about 40 customers and folks within our niche part of the industry, and what we learned from them is that they were really frustrated of launching their CubeSats and experiments to space because they had to make their experiments and CubeSats rated for manned conditions, even though there wasn't an astronaut in the same rocket, because there could be someday. They had to meet the restrictions. That usually adds something like on the order of 30 or 40% more cost to the development time of those CubeSats. Again, since our rocket will be purely dedicated to launching non-manned or personed flight, and be very optimized, very much optimized to 1, 2, or 3 payloads in terms of trajectory and launch timing. We think we can get those costs way down for a lot of our customers. And a lot of our initial customers are going to be in the academic space, from academic and civil researchers. And we don't mean just academic and civil researchers that are in college or postgrad, but all the way down to elementary and high school students. In fact, every state has a space grant consortium that can receive funds to help them develop new science projects or fun science projects that they can launch in space with us maybe, or other companies here in the U.S. And NASA itself has additional funding to also support students and researchers from elementary school right through college years. And so our initial market is to focus on assisting students from any county, any town across Maine, but of course across the country, and ultimately across the globe, to do research in space, suborbitally and then orbitally.
Awesome. And so another interesting way that we're able to keep costs low, of course, is having a small team. I don't know how good this figure is, but I read that in America alone, there's like 120 companies that are preparing to compete for this emerging small launch market. And most of those companies have significantly more employees than we do.
Sure. So that is, having been a part of the Alt-E team, a renewable energy company, been around since 1999.
Let's talk about that for a minute. Let's talk about how you're basically like the Elon Musk of New England.
I think that's an exaggeration, but
okay, fine, the Tony Stark of New England.
Right. I just need more of an attitude and a lot more money. One thing, when I started that up with Nick Albright and Jason Federspiel back in '99, we did that with blood and sweat equity, started from the ground up, and it was a lot of hard work, just like bluShift, but we did it organically, and we grew it with its own funds and its own revenues to where it is today. And it's really successful today, once again, because we have a compact team, but also because we have really capable individuals on there. And that, in many ways, is very similar to bluShift. We have a core group of very capable people, and we are growing this organically, and we're planning to keep the team tight, because when you look at the marketplace for launching suborbital payloads to space or orbitally, you can see that the potential market, in some cases, there's less value in 1 year than the cost of running a company with 100 or 200 people. So we're trying to keep our expenses low and our headcount not crazily high, besides the fact that we can't afford it, but so that we can have a sustainable business into the future. Not one that's here for today or tomorrow, but one that keeps on running and running off of its own revenue profitably. And that's not easy to do in the space industry. You need a lot of money up front to do things like this launch here. And then the next launch, we will need quite a bit more. We will be going to the outside world to seek investment, to develop our fully commercialized launch vehicle, suborbital launch vehicle called Stardust Rogue.
And correct me if I'm wrong, but it is our stated goal in the next 5 years to create 40 aerospace jobs here in Maine.
That's correct. That's right. Yep. And I hope that whether or not we're successful here today, or if we end up launching and having to scrap the launch for another date, I hope that we serve as an example of what Mainers can do, and whether it's another company who starts up as a rocket company, or kids who are students today and want to start up a new satellite company, or want to develop a new software company for downloading data to analyze data from space. I hope that we serve as inspiration to kids here in Maine, but anywhere that might be a rural state, and they might not think, well, we're not Florida, we're not Texas, we're not California, but we can do it too. And to have that go-gettedness and that sense of independence that you can kind of get from more rural states such as ours. And so I hope, if nothing else, we serve as an inspiration to other folks, and especially kids.
Yeah.
I think that I need to, my alert system is binging me, and it's telling me that I need to get back with the team here, so I'm going to have to hand over the microphone back to you, Seth.
Awesome.
But I'm happy to answer the questions post-launch, or if we scrub it, answer any final questions that people might have later on.
All right. Thanks, Sasha.
Thank you, Seth.
A busy guy, especially today. Always nice to chat. Well, if you have questions for Sasha specifically, maybe if you can note that in chat, and I'll try and take them down as they roll on by.
Plug out and start filling, so I can start filling.
Got a couple already here. Time Oakland asks, are we actively hiring? Not right now. You can send a resume to marketing@bluShiftAerospace.com. We'll keep it around. Mike Pafford asks about barge launching and the benefits of it. Well, barge launching is tricky, right? Because that's a whole new system that can have malfunctions when you're trying to get something as complex as launching a rocket done.
I wish I could have seen the face when it was active.
The advantages are mobility, being able to move that barge wherever you need to go to launch, so long as it's on the water. Can open up new launch windows that you might not have if you're just stuck on the ground. It helps with exclusion zones. Of course, a certain amount of area around the rocket, no one can be there for safety. And even in Maine, which is known for having a pretty low population density, it is really hard to find a place to launch a rocket. And so when we scale up and start launching to orbit, it may be simplest just because of the exclusion zone, just to get away from anybody for safety, to just head out to sea. There are some companies that launch from barges today. I think the main one is Copenhagen suborbitals. So we know that as long as you sufficiently stabilize that barge, which does become a challenge as the rocket gets bigger, but it is feasible. And then at some point, the rocket may be feasible to just launch from the water, like the old Sea Dragon concepts. Oh yeah, and one more thing about barge launching. Many launch sites, especially for orbital launch, are coastal. The nice thing about a barge is as the sea level rises, the barge, of course, rises with it. So it may become not just convenient, but a necessity.
No, I'm just not.
Our Journey UI asked if we need to have a self-destruct system on the rocket. For a rocket this small, flight termination is basically just cut the oxidizer flow. But as we scale up, that's something that we also have a couple plans on the drawing board. Donna Reggio asks about recovery plans. In all seriousness, those recovery plans may involve snowmobiles. Stardust has a nominal flight and landing. It'll be within a couple hundred feet of the launch tower in this nice wide open space. And we could carry it back, but boy, a snowmobile would be more convenient. Kathleen Holly makes a good point about CO2 coming from the fuel. It is a combustion reaction going on there as the fuel and the oxidizer mix. So carbon dioxide is produced and released as the rocket, fires its engine. Now, one of the things that makes our fuel unique is that as you produce more of it, it absorbs much of that carbon dioxide back into it.
I'd be the same way. I'd be like, but they would just.
So it's a carbon neutral rocket fuel, which can greatly offset the this rapidly growing industry of small satellite launch. Offset its carbon footprint. Sorry.
Yeah.
Now, if you're just joining us,
Maybe there's a challenge.
welcome. It's a bluShift Aerospace live stream of the launch of Stardust 1.0. This is our prototype sounding rocket demonstrating our bio-derived fuel in flight
But it is cool because you
out
get to
of
see this.
Loring Commerce Center, the former Limestone Air Force Base.
And then
Sorry, Loring Air Force Base in Limestone,
in my
Maine.
memory, I remember like 5 minutes later hearing a little bit or something. I don't know if that's true. Yeah.
Indications are weather may improve at 2 to 3 p.m. Eastern. So we will evaluate at that point whether or not we can safely conduct a launch.
That would be really fun to watch.
All systems are go on the vehicle,
I would have loved to have watched the shuttle land. And then land.
filling the oxidizer tank now and
Yeah.
holding for weather.
I love, I mean,
Chicken Dick over suggests we should make some merchandise. We actually do have some merchandise through Spreadshirt. If you go to our website and click on the merch button, you'll get redirected. There's shirts and coffee mugs and a couple of phone cases, things like that.
Yeah.
as we wait here, might as well introduce you to the members of the team. So earlier, you get to hear words from Sasha Derry, founder and CEO. He founded a solar retailer, Alta East Store, in 1999. It's now a $24 million a year organization and acquired Real Goods, I think the first commercial retailer of solar panels in the U.S. Acquired them in 2019. Founded bluShift in 2014. Brooke Halverson, our lead test engineer, is responsible for working on performance testing logistics, manufacturing, and hybrid rocket motor assembly and testing. Luke Sandin, our senior mechanical engineer, assists with performance testing, oxidizer system design and evaluation, MATLAB code development and staging simulations. David Hayrikian, mechanical engineer. David Hayrikian, mechanical engineer, experienced in 5-axis CNC milling and founder of Maccabee Tech. He's responsible for CAD/CAM development of the hybrid rocket motor components, developing production processes. Our executive assistant is Bonnie Etheridge. Kind of keeps us all in line. Matt Parker, technical advisor. Led a test engineering team at SpaceX where he helped develop, qualify, and produce the Merlin engines for the Falcon 9 launch vehicle. Oversaw development and operations of the Rutherford engine for Rocket Lab's Electron small sat launcher. And now manages the engineering team at Fiber Materials Incorporated to develop advanced composite materials for missile defense and space systems. And I am Seth Lockman, Communications Director, in charge of public, media, and government relations. I also handle bluShift Web. bluShift people you should know are interns funded by the Maine Space Grant Consortium's Maine Aerospace Workforce Development Program. James Giltner assisted with the layup of carbon fiber fuselage and main rocket casing, wired recovery, tether and quick disconnect arms, helped with on-site testing and rocket stacking. Ben Lemieux is a mechanical engineering major, wants to focus on rocket engines and aerospace engineering. And he was instrumental in rewiring our upgraded test stand when, under the NASA grant, we moved from an engine with a 4-inch diameter to a 6-inch. Kaylee Gallant helped model oxidizer behavior in the tank during flight. Contractors to thank: Gerard Desjardins, working on programming for the flight computer. Steve Savoy, composites expert, owns Savoy Composite Solutions, focuses on tooling design, process management, equipment evaluation and upgrades, workflow analysis and quality compliance. And at bluShift, Mr. Savoy manages design and manufacture of all composite components in the Stardust launch vehicle. Michael Ostermecki is a mechanical engineer and parachute rigger extraordinaire. If you're just joining us, this is bluShift Aerospace, a live stream of the Stardust 1.0 launch. This will be Maine's first commercial launch and the first commercial launch of a rocket powered by a bio-derived fuel. Right now, all systems are go on the rocket. We're holding for weather, hoping skies will clear as forecasted between 2 and 3 p.m., all the way up to our flight ceiling of 5,200 feet. The clouds do appear to be receding a little bit, but of course the final decision will be made based on weather reports. Eric Emery asks, are there plans for launches in Brunswick in the future? And the short answer is no, but you would never launch anything out of Brunswick. It's too densely populated. There's buildings, people, roads, that it just wouldn't do. Now you could control a mission from Brunswick, kind of like how. Just a second. All right.
Should we not bother filling that, or should we fill it?
I get my weather reports from rocket engineers, and what Mission Control is advising at this time is that the weather conditions are worsening. Cloud cover does not look like it's going to recede for 2 to 3. we can shoot for 3 to 4 just as a formality, because you always just keep trying. But barring a real surprise here, just leveling with everybody, it looks like the chances of a launch are not great right now. But that just means that we'll get to do this again next week. So, I believe I was answering the question, will we ever launch from Brunswick? And to make a long story short, no. For a rocket launch out of Brunswick, it just wouldn't work. You can't do that out of well, for Maine, it's a city. Now, with that said, it is possible that similar to what Virgin Orbit plans to do, or what Pegasus was, that launch system. Certain rockets can kind of be, slung under a 737, flown up to, above the densest part of the atmosphere, and then launched. And something like that could be done. Brunswick has, perfectly good runway at the executive airport. But for us, for rockets, vertical launch, if you will, Brunswick is not an option. It could be a good option for mission control, for data storage and processing, and business incubation, which is ongoing. Actually, we are one of 2 rocket companies in the state, headquartered at Tech Place at Brunswick Landing. Now, where would bluShift launch? Well, for suborbital, we'd love to see the spaceport develop the former Loring Air Force Base, and maybe get up here a little more often. For orbital launch to polar or sun-synchronous orbit, which isn't something, it's not the only thing we can do, but it's the market that we want to go after. To do that safely, we really need a coastal launch site, or if necessary, we could look at a barge launch or something like that. So that would be either in or based out of coastal down east Maine, somewhere in Washington County, probably. Elizabeth Kettner asks, what is a commercial launch? That is just a launch with paying customers, and bluShift Aerospace is well, it's not a government entity, right? It's a company or a private entity. And so when we launch something, it would be a commercial launch. Mike Pafford asks, what are the 3 logos on the rockets? Glad you asked. So in our current view, the top decal is the bluShift Aerospace logo. Let me see if I can make it a little bigger on the screen here. So that's what you're seeing, just much farther away. The middle one, that decal is something we're all very proud of. It says Made in Maine. And then below the interstage at the top of the engine section of the rocket, that's the logo of Rocket Insights. They're one of our payload customers for this mission. Now in the chat, someone advised that I might be pronouncing this wrong, so apologies if that is the case. But Rocket Insights wanted to sponsor our launch. One of their partners had a personal connection with the state and thought it was really great what we were doing. And so they're sponsoring the launch, and they're flying a CubeSat with us. Their enclosure will contain a traditional Dutch wafer cookie called, and this is where I hope I'm pronouncing it properly, stroopwafels. Kind of an homage to their Amsterdam-based parent company. So those are the 3 decals from that angle. And from this angle, you can see down at the bottom another Made in Maine decal. And on the interstage, just a Stardust 1.0. Elizabeth McGovern asks, how heavy is the rocket? Unfueled, I believe it's about 540 pounds, and then fueled, it's close to 600. A couple questions about the timing of the launch. We're targeting 2 to 3 p.m. However, the outlook is poor. Weather forecast does not suggest that we'll have clear skies at that time. We're going to continue holding just because we can, and we can always hope that the weather will cooperate and improve. First trip. My God. It's been a minute. How are you doing? Asks if I can speak to career opportunities in the future at bluShift. So it is our stated goal to create 40 aerospace jobs here in Maine in the next 5 years. And we also support the initiative to create a spaceport here in Maine, which over its lifetime is estimated to create something like 75,000 jobs. We're not hiring right now, but depending on the results of this flight, we might be hiring very soon. You can reach out to express interest. Probably the simplest way to do that is just through the contact page on our website. But if you send a resume to the marketing at bluShiftAerospace.com, I'll see it. David Stevens says, hopefully still edible after recovery, presumably in reference to the Stroop waffles. I like telling the engineers, don't toast the Stroop waffles. Space Gnome asks how much thrust the engine can generate. So the engine can burn at 2 Gs, which then, fighting the Earth's gravity, means it can accelerate straight up at 1 G. Oh, here's a good one. Reese Collins asks, what's the difference between polar orbit and the low Earth orbit? So the term low Earth orbit really speaks to how high the orbit is going to be. The term isn't formally defined, I don't think. But basically, from the moment that you can get to a stable orbit, which is a little bit above the Kármán line, out to a couple hundred miles is usually what we mean when we say low Earth orbit. Now, a polar orbit, that refers to the inclination of the orbit. So rather than its altitude, we're saying if you imagined a flat disk extending out from the Earth's equator, would your orbit be perfectly on that kind of a plane, what we call the ecliptic, or would it intersect with that plane? And assuming it's assuming that there is an inclination, then you can ask, what is that angle? And if the angle is 90 or negative 90, then you're going to pass over that planet's poles. So you can be in a polar orbit and a low Earth orbit. You can be in a polar orbit and a high Earth orbit. You cannot be in a polar orbit and a geosynchronous orbit. Quite welcome, Reese. Kindness asks if we plan on going orbital, and the answer is yes. We plan to develop our presence in the suborbital market first, and then work on a 3-stage to orbit launch vehicle, which we're calling Red Dwarf. The plan is to focus on launching from a high latitude to a polar orbit, but it could reach other orbits as well. The beauty of our 30 kilogram payload capacity is that the CubeSat is the primary customer. There's no ride sharing. And so if they need to go to a weird orbit, all they need to do is find 2 or 3 other people that also want to go to that same orbit, and we can just do a custom mission. And even on the drawing board is launching a single CubeSat. Ooh, Riley Dunn mentions you could be in a polar geosynchronous orbit, but not polar and geostationary. Well, rest assured that I will be Googling that this evening and educating myself. I'll be using Google Scholar, don't worry. Mike Underwood asks, do cold temperatures affect launches? Good question. The biggest effect that the temperature has is on valves. Condensation around valves can turn into ice, and so we want to make sure that doesn't happen. Easiest way to control that is just heating. Rocket Guy asks, would you be using Alaska launch site for an orbital launch? That must be a reference to Kodiak. It's certainly an option. Yeah. If we can launch from Maine, though, we might not need to launch from an island. Getting a rocket and all of its payloads to an island can be a little difficult. But what's really difficult is realizing that you forgot that one part back on the mainland. Oh, thank you for the clarification, Christian Bradley Hubbs writes, geosynchronous just means the orbital period is 24 hours. Geostationary is geosynchronous that hovers over the same point on the surface. Alright, well I just learned something rather publicly. Thanks, guys. Drew Goff asks, will you guys be developing reusable rockets? That is on the drawing board. Aiden Eisenberg asks if we're ever going to design or operate a orbital launch vehicle that carries more than 30 kilograms. Currently, we don't plan for that, but the engine is going to be fully modular, so in time, Starless Rogue and Red Dwarf will be more like standard templates, more like guidelines than models. So if the Marvels can be configured in such a way that we could launch a larger payload and the mission called for it, I don't see why not. But we're dealing with hypotheticals that are years away. The reason for going with that 30 kilogram payload is, well, we touched on it earlier about CubeSats being the primary payload. And based on our research, that's where the demand is. MC Official Plays Space asks, will the rocket be landing intact? That is the plan. CB Manley asks how we keep the rocket stable for the first few seconds before thrust takes over. And that's a really good question. We've got that launch rail. The guide tower is about 72 feet long. A little longer than average. In part because Stardust 1.0 has a little bit of an irregular construction with steel in there. It adds weight to the overall structure, and so it just takes a little longer to get up to headway speed. Airbus 390 asks, how many stages is Stardust 1.0? It's a single-stage rocket. However, on descent, it will split into the engine and payload sections, which will then remain tethered together as the rocket descends on parachute. So there is a separation, but there's only one stage. Oh, Kendra Green asks, my science class is watching the live feed and would like to know what the rocket is fueled by. Well, that's just terrific. Hi, class. Study hard. So I can't say too much about what's in the fuel. It's our secret sauce. It's proprietary. I can say that it's a hybrid rocket engine, meaning that we have a liquid oxidizer and a solid fuel. Most rockets are either totally liquid, so they have a liquid oxidizer, liquid fuel, or solid fuel, where you have the oxidizer and the fuel suspended in a kind of a gel-like substance. So we have a little bit of each. With the solid fuel, you can get some really terrific energy density, a lot of delta V, a lot of bang for your buck. And with liquid oxidizer, you have start-stop ability, throttle ability, and with only half of the systems being liquid, you save a lot on parts and plumbing, and there's fewer components that can malfunction, and you save weight and cost and all kinds of things. And then with the solid fuel, it's incredibly stable. It's got a 0 TNT value. So if hybrid rockets are so great, why don't we see them everywhere, right? And the answer there is because you're passing the oxidizer through or around the fuel core in the reaction chamber. As the fuel is consumed, as the rocket operates, the combustion chamber changes shape, right? And this is happening while the temperature and pressure are changing around the rocket. So it can be pretty difficult to sustain a stable reaction, especially at larger scales. And so that's one of the big technological hurdles that we had to overcome, in addition to inventing a new rocket fuel. If you're just joining us, this is bluShift Aerospace. We're doing a live stream of our launch of Stardust 1.0. This will be the first commercial launch in Maine, the first launch ever of a commercial rocket powered by a bio-derived fuel. Quick update on the weather. We were targeting 2 to 3. Now we're looking at 3 to 4. Odds of the weather improving at this point are pretty low. We did see a question in the chat from NASA asking when will we reschedule to if we have to scrub. And the answer would be after the long weekend, after Martin Luther King Day. So potentially Tuesday or Wednesday. To launch, we need low winds, which we have actually. There's abnormally little wind for Limestone in the middle of the day, in the middle of the winter. Clouds are the main issue. The rocket's going to reach 5,200 feet above sea level, and we need less than 50% cloud coverage up to that height. At this point, cloud coverage pretty greatly exceeds 50% at and around apogee. Cloud ceiling appears to have lifted somewhat just based off of my own observation here. But it's not, well, cloud cover is not less than 50% all the way to 5,200 feet. If we do have to scrub today and are unable to launch due to weather or another issue, then yes, as soon as we determine a new launch date, we will make sure to let everybody know. It'll be all over our social. We'll schedule another live stream. We'll update the website, Eventbrite, Google Events, however you found out about us. We'll make sure to keep you posted that way. Well, thanks everybody for your understanding and support. It's definitely a little bit strange to work so hard on literal rocket science and then be looking at a scrub for clouds. All right, it looks like Sasha is about to do an interview with the press, so I'm going to duck the mic for a couple minutes while he does that. If you're just joining us, this is a bluShift Aerospace live stream of the
Well, thank you guys.
launch attempt, our first launch attempt for Stardust 1.0.
If it's ours, no.
So, I've got kind of a tough announcement here.
We have one like it that we had the sanitizer.
We are ceasing launch attempts for today. The launch is scrubbed due to weather. The cloud ceiling just will not cooperate. So huge thanks to everybody who joined and stayed on the live stream,
Tell Sandy
even when we weren't so sure about the launch window. And there's been amazing comments and questions in the chat, and it's been really great to see all of you. And thanks to all the engineers and the volunteers who worked so hard to secure the field and coordinate traffic and everyone who put, years and years of blood, sweat, and tears into this launch attempt. We'll try again, probably on Wednesday. We'll have a meeting, finalize that, and I'll make sure everyone gets updated wherever you are, however you find out about bluShift. It's definitely not the best feeling, but the rocket's fine. We'll just try again on Wednesday. Well, thanks everybody for your supportive parting words. All right. This is a bluShift Aerospace live stream of a launch attempt for Stardust 1.0. I described due to weather. We're going to attempt again probably next Wednesday. Keep an eye on our social platforms on Facebook, Instagram, LinkedIn, and Twitter. We'll let you know as soon as we confirm that date. Except for the weather, I'm happy to report that all systems are go on the rocket. Support systems for the rocket on the network. As the dress rehearsal goes, this was a good one, and I think everyone's a little, probably a little disappointed, but looking forward to Wednesday. Thanks to everybody who came out to watch the launch and everyone who stayed in chat for your support and just really excellent questions.
I could hear a train last night as we were working at like, and I was guessing that it was probably
We're gonna wrap this up, so
coming from that way, and it sounded pretty far away.
for bluShift Aerospace, I'm Seth Lockman. Over and out.
Yeah. I've looked at the train tracks around here, but it's hard to tell if they're active or not by satellite. So. Yeah. Yeah, crossing, and then you cross a couple of things. I was wondering about that. Yeah.